I'm going to talk about the law of cosines. All right? The law of cosines is a useful formula with respect to triangles. Now, let me spell out what the law of cosines is. So give me a minute to make a picture. Suppose that I had a triangle with the vertices denoted by the capital letters A, B, and C, and with the side lengths denoted by the lowercase letters A, B, and C. Okay? And suppose that the length of the side opposite angle A was denoted by lowercase a, and the length of the side opposite angle B was denoted by lowercase b, and the length of the side opposite angle C was denoted by lowercase c. All right. For that triangle, and by the way, I haven't set any constraints on the triangle. It doesn't have to be a right triangle. It doesn't have to be an isosceles triangle. Really, it can be any triangle. So for those given angles and side lengths, the following will always be true. A squared plus b squared minus 2ab times the cosine of the measure of angle C is equal to side length C squared. Okay? That is the law of cosines. Few observations. Notice that it's very similar to the Pythagorean theorem. Okay? In fact, it's used in a lot of similar situations. The Pythagorean theorem is useful when you know two side lengths of a triangle and you want to know the third side length. So you can use the law of cosines for that as well. Now the difference is that the law of cosines requires you to know the cosine of a certain angle measure. Okay? The good news, however, is that the law of cosines applies to any triangle, not just right triangles like the Pythagorean theorem. All right? One last comment. The angle measure that you need to find the cosine of, that one is the angle between the sides that correspond to A and B. Okay? Look at the picture, study that. Make sure you understand the law of cosines and which side length is corresponds to the term on the right side and how that relates to the angle. Okay? Now I'm going to prove that this equation is always true. So let me make a bigger picture of a similar triangle. And then we'll continue. All right, so I'm also going to draw all three altitudes of this triangle. Remember that altitudes are line segments perpendicular to a side of the triangle, and they have endpoints. One endpoint is on a vertex, and the other endpoint is on the side opposite that vertex. And notice that the altitudes are perpendicular to, they're each perpendicular to a different side length, a different side. All right, so we've formed several right triangles, and using the definition of cosine, we can determine the length of the lots of those right triangles formed. Okay, I'm specifically interested in the legs of the right triangles that form the lengths that correspond to lowercase a, b, and c. For example, the side opposite angle A, that one is divided into two pieces, and one of those pieces has the length b cosine of angle C. The other piece has the length c cosine of angle B. Now, to see why those two lengths are correct, think about the corresponding right triangles. For example, can you see on the left a right triangle with a hypotenuse of length B containing angle C? If you think about what the cosine of angle C is equal to, you will see that from that ratio you can work out that b cosine C is that the length of that piece. Okay? Likewise, if you work out what the cosine of the measure of angle B is, if you use the ratio that's equal to that, it'll involve the hypotenuse of length C. Okay? If you use that ratio, you will work out and you'll see that the other piece of the bottom length is c cosine B, or the measure of angle B. All right? So I will, and in a similar manner, you can work out the two pieces that for each black side of triangle A, B, and C. So the side with length B, the two pieces there are, let's see, C cosine of A, that's the little piece, C cosine of A, and then A cosine of C. Okay, for the C cosine of A, I used the thin right triangle with the hypotenuse of length C containing angle A. To find the length that's A cosine of C, I used the right triangle with the big right triangle with a hypotenuse of length A containing angle C. All right. Now for the other leg, the other side of triangle A, B, and C, I have A cosine of B for the big piece, and B cosine of A for the small piece. All right, so those green lengths are the lengths of the two pieces that add up to, each of those pairs adds up to A, B, or C. So I can write down the following equations. A is equal to B cosine of C plus C cosine of B. B is equal to C cosine of A plus A cosine of C. C is equal to A cosine of B plus B cosine of A. And now let me multiply the first blue equation. Let me multiply both sides by A. So I will get A squared equals AB times the cosine of C plus AC times the cosine of B. And for the second blue equation, let me multiply both sides by B. So I'll get B squared equals BC times the cosine of A plus AB times the cosine of C. And then for the third blue equation, I want to multiply both sides by side length C. So I'll get C squared equals AC times the cosine of B plus BC times the cosine of A. Now I'm going to add the A squared and the B squared together, and I'm going to subtract from that sum C squared. And I know that that has to equal the sum of the two right sides, that correspond to A squared and B squared. And from that sum, I'm going to subtract the right side that's equal to C squared. All right, so what will that give me? Well, I hope you can see that if I was to sum the first two right sides and subtract the second right side, the third right side, that these two are similar. When I subtract, I will get these cancel, and I will get these cancel. So the only thing that I will have left is the sum of the two terms that I've circled in green. So that will give me 2 times AB cosine of C. All right? And that is equivalent to the law of cosines, the way I originally wrote it. So therefore, the law of cosines has been proved. Okay? Now, it's not so important that you know how to derive the law of cosines as that you know how to use it to solve certain math problems. So let's do some examples now. Give me a minute to make a picture. Suppose that we know two side lengths of a triangle, and we know an angle measure as denoted in the picture, and we wanted to know the length of the third side. Can we do that? And the answer is yes, using the law of cosines. So using the law of cosines, 19 squared plus 26 squared minus 2 times 19 times 26 times the cosine of 42 degrees, that's equal to L squared. So L, therefore, what we're looking for is equal to the square root of 19 squared plus 26 squared minus 2 times 19 times 26 times the cosine of 42 degrees. So you can punch that into a calculator, and you can see that that is equal to approximately 17.4. So 17.4 centimeters is our approximation for the missing side length. Okay? So if you understand that, would you please try to do an example? So once again, give me a minute to make a picture. All right, so I've drawn a very thin triangle, and I've identified two side lengths, 80 meters and 100 meters. I've also given you the measure of an exterior angle. So with that information, can you calculate the length of the side denoted by the letter L? So pause the video and work that out now, please. All right, so I'll go ahead and work it out as well. So using the law of cosines, 100 squared plus 80 squared minus 2 times 100 times 80 times the cosine, and now we don't want to take the cosine of 20 degrees, but rather the cosine of 160 degrees. That's the measure of the angle of inside the triangle, and that's equal to L squared. So L is equal to the square root of 100 squared plus 80 squared minus 2 times 100 times 80 times the cosine of 160 degrees. And you can put that into a calculator and see that that gives 177.3 meters. Okay? Now, here's another type of problem I'd like you to try to solve. Determine the largest angle measure of a triangle with sides of length 20 centimeters, 30 centimeters, and 40 centimeters. So with just that information, can you find the largest angle measure of that triangle? Pause the video and work that out now, please, if you like. All right, so I'll go ahead and work it out as well. So I will first draw a picture. Now, you may know that the largest angle measure, well, the largest side length will be opposite the angle with the largest angle measure. If you didn't know that, you can still apply the law of cosines 3 times to get all the angle measures, and then you can see which one is the largest. But the largest angle measure will be the one that the side with length 40 centimeters is opposite. All right, so using the law of cosines, by the way, let's call that angle alpha. So let's see, 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of alpha, that's equal to 40 squared. So therefore, moving terms around, 20 squared plus 30 squared minus 40 squared is equal to 2 times 20 times 30 times the cosine of alpha. So the cosine of alpha is equal to 20 squared plus 30 squared minus 40 squared divided by 2 times 20 times 30. Now, to find alpha, we're going to have to take the arc cosine of both sides. And you can use a calculator to see that that will give that alpha is approximately 104.5 degrees. Okay? Now, let's do one more exercise. All right. What is the largest angle measure of a rhombus with sides of length 24 feet and with the longest diagonal having a length of 36 feet? So pause the video and see if you can work that one out. All right, so I'll go ahead and work it out as well. So let me read the question again. What is the largest angle measure of a rhombus with sides of length 24 feet and with the longest diagonal having a length of 36 feet? So let's first make a picture. Alright, so the lengths of the sides of the rhombus are all 24 feet. And the longest diagonal has a length of 36 feet. So the largest angle measure, so focusing on the triangle with that has a side of length 36 feet. So I've split the rhombus into two congruent triangles, and the largest angle measure is going to be the one between the two sides that are congruent. So let's call that alpha. All right. So we can use the law of cosines to find that. 24 squared plus 24 squared minus 2 times 24 times 24 times the cosine of alpha is equal to 36 squared. So let's move some terms around. 2 times 24 squared minus 36 squared equals 2 times 24 squared times the cosine of alpha. So the cosine of alpha is equal to 2 times 24 squared minus 36 squared, all divided by 2 times 24 squared. And we can take the arc sine of both sides with a calculator, and that'll give us that alpha is approximately 97.2 degrees. And I hope